Odyssey, and the mission is to foster quantum literacy in the society. He is also a PhD candidate at Durham University in UK, and he's studying theoretical physics and quantum computing in particular. The lecture will be titled Quantum Literacy in the Future Education and Transdisciplinary Problem Solving. Now I will leave it to Laura. Thanks again for coming today.
Thank you for the introduction, Özlem. Hi, everyone. Okay, so let's go directly on our homepage, quarksinteractive.com, because I think no matter what words I would use, it would fail in comparison with the trailer we spent months making, which has the purpose to show in 3 minutes what we are all about, to show the extent of activities we are undertaking as a company and the aim of the mission. Yeah, because for us, it's quite important to not just be a company that you would normally see, but actually push for better science and for better knowledge acquisition in our society. I hope you can see my screen, and I will minimize this. And yeah, let's quickly watch our mission video. If the sound doesn't come through, let me know. So the whole point of what we are doing is based on this beautiful quote from Richard Buckminster Fuller. He was a well-known architect. And the idea is if you would like to bring a new way of thinking, and yeah, we are in quantum worlds, what we are pushing for is understanding quantum reasoning, understanding quantum computing as a way of creating logical sentences, as a way of using those logical sentences in order to do meaningful computations. Solve problems using quantum reasoning. That's what the company is about, and that's what we are pushing for in our society. So the idea is we are creating a tool.
Since the birth of humanity, our ancestors who survived and thrived were the discoverers, the adventurers. They had problems to solve and plans to lay out, and as a result, stories to tell. The more effective they were at tackling nature's challenges, the bigger their stories became. Specialist tools had to be made to harness the power of their stories, ideas, and reasoning. They could not afford to lose them with time. They kept them safe. But too often, valuable information became accessible only to a select few. Yet with enough common stories and understanding, civilizations were born. Leaders and societies who thrived expanded their knowledge. Information literacy, as a result of sharing this knowledge, was key to their longevity, whilst ignoring or hoarding it out of ignorance, fear, and hatred was the beginning of their downfall.
Not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
Although we've reached a new age, the age of information, where more people on Earth have access to more information than ever before, what's holding us back from solving these problems? Our old ways of accessing and processing information brought us solutions because the passing of time allowed it, whether we were aware of it or not. We may not have time on our side anymore because of the pressing nature of our problems, but we may have found a most powerful ally, a new way of reasoning. So powerful that we are convinced it is the very logic behind the fabric of our universe. We named it quantum computing. However, the tremendous potential of this tool is not enough if we cannot even begin to grasp it as a society. With this in mind, at Quarks Interactive, our mission is to make learning quantum computing come as easily and naturally as having a good time, and with that, introduce quantum literacy to every single human being. Therefore, we've made Quantum Odyssey, the first video game to make quantum computation fun and accessible to people of all ages, no matter their background. With Quantum Odyssey, the idea of applying quantum reasoning becomes simply a matter of understanding and solving visual puzzles. Play your way through quantum computing, explore carefully crafted learning modules that will open the doors to this new way of reasoning. Browse through an interactive encyclopedia filled with all the quantum knowledge you'll need. And to top it all, no maths required ever. Be part of the quantum literacy revolution. See you in Quantum Odyssey.
So this is the trailer for the product Quantum Odyssey, and yeah, the main thing we try to do there with it is to create an environment that's accessible to everyone, that's inclusive, that's open and easy to navigate and easy to play with, to interact with, to do different things, to try different ideas in. And this environment is literally looking like a puzzle game. It is a puzzle game. So the moment you master the rules of the puzzle game, you are getting good at playing the puzzle. Quite good. You could be very good in a way that you could be competitive at it. Yeah, or play against your friends and get really good, and we'll soon have ranking scores and leaderboards and ways to share puzzles with the community. All of that is because the rules of this game, so the actual rules, all the rules in which the game is based upon, are the rules of quantum computing gate model framework. So by mastering the rules of playing this video game, like you're playing Tetris, you're mastering the way you're placing those tetriminos, and through that, you're actually learning how to construct an algorithm using the gate model framework on hardware that you normally see on IBM, Rigetti, well, D-Wave not, because it's an adiabatic, but yeah. So this is a game that you're learning, and as you're learning it, you're actually becoming really good at doing quantum computation, in a sense, building quantum algorithms. Why we've done that? Because we feel that we live in quite a quantum literate world. So although we are in the second quantum revolution, which is the fourth industrial revolution, yes, we believe that there are more things about holistic medicine using quantum phenomena. Well, in a matter of just saying that they use those phenomena, then there are really easy to understand resources out there for people who actually want to learn quantum computing, and we very often see people outside STEM who also want to learn quantum computing. So we thought that if we can encapsulate this need, this want that people have right now to understand how the universe works and how we can use this very logic on how the universe works and solve problems we care for, we've done a lot of research in order to develop the idea of quantum literacy. So we tried to coin the phrase quantum literacy and create, in a sense, levels of achieving quantum literacy. This is a very, one of the, well, I would say, well, it's my first paper on the topic. We'll soon have another one which discusses more in depth certain concepts and also shows the data behind the first experiments we've done with the product. This paper, I would really advise if you're an educator, if you're someone who is looking for a really easy way to get people interested in STEM, because the game goes beyond maybe just teaching quantum, but you can learn linear algebra, you can learn about complex numbers, and many other things. You can learn about matrices and their properties, what a bipartite, what a unitary matrix can do by simply exploring Quantum Odyssey. This paper shows that, well, if you're looking at the whole idea of scaffolded learning and the theory of knowledge acquisition, because, well, we wrote it with people who are experts in education. Laura Smith and Helen Cranman are professors in education at Durham University. There is a really big gap there. There have been educational games that kind of dilute the concept of the rigorous body of the knowledge which needs to be acquired by the person who's studying it. And there are games which have some education elements. For example, quantum chess. You're learning chess, but you're also using quantum phenomena. But there is, at the time we were writing this, we couldn't find a game that the actual rules of the game are the actual rules, or the actual knowledge body, which is supposed to be acquired, all the rules. So there is no additional sophistication added. Purely simply, the rules of the game are rigorously connected to the actual mathematics behind doing gate model quantum theory. So this paper I would highly recommend to give it a read. And yeah, so we built a tool. Yeah, unfortunately, this header here doesn't show. The idea is why we made quantum literacy. Well, because we strongly believe that it's not really necessary to give this way of thinking in a descriptive way, but perhaps it's more adequate to how we've been working so far, as you've seen in the video. First, we built a hammer. Why did we build a hammer? Because we wanted to nail things, yeah? We built an axe in order to cut trees, yes? So the knowledge acquisition happens more naturally for us as a species, I believe. I strongly believe this. If we design the tool, we give the tool, and then people just play with it and explore it, and then the knowledge acquisition will be a natural process. It will not have to be forced. Yeah, so how does the game look like? This is a very old version, by the way. So you could do any kind of quantum physics experiment in the game, as long as you could describe it in a binary fashion. You would have a bunch of binary strings at the beginning, and the boss you're seeing is literally the quantum state vector.
Laur, do you have a presentation right now? Because
you're not seeing anything.
No, we are stuck.
Wow, fantastic. Okay. All right, there we go. Do you see it now?
Yeah, great, thanks.
Okay, yeah, so there were a bunch of slides which we missed. Not much of a problem. Yeah, so the idea which I was discussing right now is that there are visual ways that are equally as powerful to represent the ways of mathematics. If you understand mathematics as the most simplest, most compact way to explain something, then I believe there is a different, a more even better level, and which is the visual level. Yeah, and this visual level could potentially go beyond just understanding the pure concepts, for example, such as the one behind the Honge-Mendel effect, but actually would allow you to go beyond that and visualize phenomena in your head and visualize new ways of using these mathematics further. Well, the knowledge further. Yeah, mathematics doesn't have to be the ultimate form in which we express knowledge. So that's what the game is. It's kind of a safe space in which you could sit down in an evening and just learn everything about gate model. You would start from the beginning. What's a bit? What is binary? Why binary is a cool thing to have? And go as beyond as being able to do basis transforms, discover eigenstates of your state vector, understand what does it mean to be in the Z basis, X basis, Y basis, see quantum interference with your own eyes. This is again something that no quantum simulator can do today, from what I've heard from others saying who are expert in the field. The game shows you exactly what happens in 2 H-gates or 1 H-gate. So what you're seeing here, all these balls coming out, is literally what's happening inside 2 H-gates on 2 different qubits. Yeah, so as long as we can show a single picture, just this picture on the right, and tell you that, look, the whole idea of understanding what's happening here is equivalent to this, then I think we are on a good pace to create a product further that can go in this direction with a very high velocity. Yeah, so all you need in order to enjoy Quantum Odyssey is a minor interest in and patience in understanding and being able to solve puzzles. Yeah, and these are just visual puzzles. That's why we hope people outside STEM can take the product and play with it. Right, so this is the core loop of the experience. The idea is, as I said, you master a new type of a puzzle game. It's like, I don't know, Match 3 and 1 or Tetris, form of Counter-Strike. If you think about Counter-Strike, it's quite simple as a game. It's just, yeah, clicking around and shooting things. You master the rules, and after you master the rules, then you're able to understand the descriptions and the explanations which are given in the game, and they are narrated. So the game contains full narration over each puzzle, which is part of the learning phase. You'll learn how to construct quantum algorithms, and maybe even beyond that, we have certain modules that teach the idea of how to encode a real world problem in the gate model framework. So it's not just about constructing quantum algorithms. We're also trying to touch topics about, right, but how do I sit down and be able to describe a problem in such a way that could actually encode it on a quantum computer? Besides that, you'll master known quantum algorithms. We have Grover right now. I think it would take about 2 hours to understand everything about Grover and all the ways you could use the diffusion operator. That's part of the game. It's in chapter 2 already. We'll start putting more advanced algorithms as the community keeps growing. So we'll try to go and have most of the quantum zoo there at some point. And yeah, discover applications. So why the platform? Well, we hope that by just experiencing Quantum Odyssey, your brain will start to think of new ideas. So what I'm hoping is that you're a chemist, or maybe you're doing some other type of physics, which is not related to quantum computing, and you just want to understand quantum computing. So we hope that you can get a 30 minutes, 1 hour experience playing with Quantum Odyssey, and those concepts and those ideas and those powerful visual methods would stick to you. And then when you go solve your big matrix of, I don't know, tensors of wherever you're computing or trying to solve numerically, then you would start having ideas that, right, I could use quantum interference right here, and I could get some quantum advantage out of it. This is a problem that should be part of BQP, if you know about complexity theory. And then at some point, as I said, and I hope this year by May, we would have a strong community in which people can solve challenges online and compete against each other. So even the person who's creating challenges gets rewarded if the challenge is fun, if the challenge is educational. And yeah, a ranking board, and let's see who are the best quantum computing experts on the planet. So this is the core experience of what we are designing, and well, it's already out there. So you could experience Quantum Odyssey today. You could go on our website, download it, and have a go at it. But as I said, it's a thing that we constantly expand. So we want to make sure that this has a complete description of everything you could do with the gate model framework. So the game will not be finished until the whole body of knowledge behind gate model theory would be finished. So we'll explore quantum error correction, and other fancy things we'll be adding as modules in Quantum Odyssey very soon. Right, I also want to show you now I have no idea what time it is, but yeah, I want to show you a bit about the research we've done using the game. We took a grant from the Biosciences Council in UKRI in the UK, and we've been to two private schools in 2 locations in the northeast of England, where we tested the game in a very prototype version of the game. So this was way back in 2020. 2 groups, 11 to 14 years old, 15 to 18 years old, and some career teachers. Of course, NDAs were signed, we passed an ethics interview, we've been through all of that. So what happened? Everybody had 30 minutes to solve 21 puzzles. I carefully designed those puzzles to not be solvable in not even an hour. That's what was going on in my head, because I had some friends who played it, who are in physics, who do computer science, and it took them a long time to solve. But we've been with those puzzles to these schools, to kids, to see how long it would take a kid to solve. And according to my expectation, a young adult would be way faster at solving these puzzles than a kid would be, especially if the young adult is also a STEM expert in some sense, yeah. So in just 30 minutes, 5 puzzles were about simply binary and switching bits with NOT gates. Another 5 puzzles were about superposition and interference using H gates in combination with Z gates and X gates and Y gates to just collapse things and get some quantum state at the end. which would be the solution. Try to do it as fast as possible. The third set was about Bell states with global phase. So the solution is not correct if you have a green red ball. Yeah, I mean, if you have the difference is if it's by global phase, the solution is not correct. So you have to account for global phase too. So this means the puzzle is quite hard. Then the last set of puzzles, which were really hard even for me at the beginning, I was still forgetting what some solutions could be. They were having different amplitudes. So the state vector was a very skewed state vector. It was just on 2 qubits, but imagine trying to find all the Clifford set of gates, which would go into solving some 4x4, 8x8, well, I think it's 4x4 matrix that has a bunch of complex numbers in it, and trying to reverse that back to unitary and bipartite matrices. So it's quite a complicated set of puzzles that we've constructed, and they had to do it all visual. So nobody has to do on pen and paper or calculate numbers, but they just had to play quantum odyssey in which the mathematics were given as puzzles. And guess what? We overestimated the difficulty level of our puzzles. So apparently everybody, including the educators, finished the first 2 quite fast, and 90% actually were able to do everything with Bell states. And apparently 14% actually reached the final stage, which for me was a big no. I was hoping nobody would get there. And one 15-year-old finished out 21, and I think he finished in about 20-something minutes. Yeah, the results for me were quite astonishing. I did not expect that. The questions at the end were quite surprising as well. So we were discussing deep quantum fundamental theory about measurement and superposition, and what does it mean when 2 H gates collide, are one next to each other, why you would get back the state you were before the first H gate. Things that I would not expect to have in a discussion with 11-year-old. Yeah. So we also, now starting yesterday, actually, I started looking at the results, parsing the data a bit, doing some data cleaning. Apparently, the first thing I want to see is, right, could they by trial and error be so good, given these are kids who grew up with, well, phones in their hands, I would say most of them, and well, like we all do today. Well, I did some checking, and well, we will have about 36 combinations possible, and apparently most of people used less than 10 gates per puzzle. So yeah, it's not trial and error. They actually learn how to do this. Yeah, most of the kids actually learned, and they could have discussions about quantum computation after 30 minutes of experiencing the game. Another beautiful thing that I was, well, since now it's a popular discussion, I was thinking about would be, would we see some gender gap? Also because we want to make sure this is gender inclusive. Half of our team is, well, mixed gender. So, well, all our team is. So the idea was to see if there is any discrepancy. And apparently there's not. So we had, apparently the game is actually very accessible and very likable by people of all genders. Then we also looked at to see if people find the screens easy to navigate, if they find the designs appealing, and if they enjoy the puzzles. The ratings are good, and this is a prototype version. So if they would be even bigger, then I would be sad because there is nothing that I could improve. And this means, well, I don't know what else to design in improving the experience. So that's fantastic. We got a lot of feedback, and that feedback resulted in a better version of the game. Other things we accounted for was questions like, we had a lot of qualitative data to play with besides the quantitative one, besides how people performed by playing the game. The qualitative data also showed us that before playing, asking the question, how interested are you in finding out more about quantum computing? And after the game, how interested are you in finding about more? 8 people actually rated higher they're interested in quantum computing. I think the fact that they enjoyed the experience, yeah, made them more open towards the STEM subject. And as I said, well, I haven't fully analyzed the data, but 90% at least, well, with 1 sigma difference, I would say, are people who don't study STEM. Yeah, these were kids who, some of them have mathematics, level A, maybe they had some computer exposure, and that's pretty much it. And yeah, 8 people rated higher. 3 people rated lower. I followed those points and I looked at the feedback they had. So yeah, most of the low rating was because nothing was working, stayed stuck at the same one for 15 minutes. There's this funny quote that a human being on average remembers only 7 things. So as I said, if the average is 36 gates, it's really difficult by trial and error to be able to finish a quantum odyssey puzzle. Yeah, we had some really positive also. So yeah, somebody said, well, he was a PhD physics candidate in a separate group we've done, that this is one of the most interactive resources to learn quantum computing at present. Okay, do we have any questions? Because, well, otherwise I could show the game.
I think it would be better if you show the game and then we pass to the question and answer part, because we have previous questions that we already have, and then we will accept some questions from the audience.
Okay, cool. Okay, let's see. Right, so to get the game, the process is quite simple. On our website, quarksinteractive.com, there is this button here. I already see the question, and the answer is right here, unfortunately, for now. And I think in 1 month, we'll also have a Mac and a Linux version available if our developing team is able to port it properly without bugs. So yeah, right now it's only in Windows, 64 bits. So Windows 10, Windows 7, you can play Quantum Odyssey. Just click this button, you'll get a launcher, and in the launcher, you'll be able first to see some videos. I would highly recommend to watch these videos. They're really amazing. For example, I haven't seen a proper explanation about probability in quantum physics and how the idea and the notion of probability differs from our normal understanding of probability. I think you all know that probabilistic events and adding more events to some event would just spread out the events. Yeah, it would be a bunch of more events to happen. But in quantum physics, and well, using quantum, the idea of quantum interference is that you could actually completely cancel an event from ever happening. Yeah, so that's the power of quantum reasoning. Once you understand that, you'll see what I mean. And that's really fascinating. I highly recommend to at least watch this video. Okay, so right now we're in the game. The logo is Quantum Venn Paradox. Another really beautiful thing that I highly recommend you guys check it out. Quantum Venn Paradox. The idea is that you could actually see the effects of entanglement with your naked eye. Yeah, just Google that. It's fascinating. So as I said, the idea is to create a really cool, safe, and smooth place that anybody could enjoy. I didn't want to make it feel like this is a learning platform, like this is some place where you need to struggle, where your head will start to burst if you feel something is not working well or you couldn't finish a certain puzzle. So yeah, that's why you got a ship, you get space, you get beautiful animations. The chapters don't feel like chapters in a book. They feel more, I think you guys could see that this kind of resembles a bunch of quarks. Well, given we can't really show a quark, we just make a big.
No, yeah, I think we are missing the game.
Okay.
Yeah.
Yeah, Zoom, I think they changed something in Zoom.
Yeah.
It's not working as usual. Yeah, so I was showing the main menu, as I said. So yeah, it's all gamified. So what you're seeing and what you would experience when you're inside it would be, right, I'm playing a video game. I really hope that the idea of learning comes second, that you no longer think about learning, but you feel like you're having a good time. You're playing a game with full music, with sound effects, with cool visual art. And you're learning by just getting good at the game. And that's it. So there is no need to focus, so to say. Yeah. And we have 3 chapters right now. So the first one teaches the fundamental laws. Second one teaches about algorithm construction. And the third one are thought experiments. We will improve these chapters, create more content. Like I said, this idea will never expire. So we'll continue adding content depending on user feedback. The chapter 1 is what I would highly recommend everybody to do. It's organized from 1 to 6 because that's what we believe would be the most natural way to do progress, but doesn't mean you can't just jump to 6. If you already know everything about bit flips with global phase and the other aspects, Well, okay. One important thing I want to show here is to say here is that we always try that, although everything is visually explained, to kind of ground it to reality. So when you're talking about bit flips, we immediately show the idea of switching on and off a light bulb. Yeah. Colorful flips, we talk about the idea of switching on and off a light bulb that has not a light bulb, different colors, but the switch operator could switch it in different ways. Yes, you can't see the effects of the global phase, but they're there. So you can imagine that this teaches how to use X, S, Z, and Y gates efficiently in order to solve puzzles. And the third one, because there's nothing in our real world I could use, I put a cat inside a box. And I think you all know what that is. That's Schrodinger's cat, dead and alive. And we are discussing here quantum superposition and entanglement, and well, how to create the famous EPRB paradox that puzzled Einstein, and he said quantum mechanics can't be a thing because of that. I don't know if you've ever seen this before, but when we're talking about GAZ states, we stumbled on the Borromean rings, this beautiful aspect in topology in mathematics. If you would have 3 rings, and you could actually connect those 3 rings in a way that no ring is actually connected to any of the other rings. Yeah, and when you achieve that, you actually achieve a maximally entangled state of 3 qubits. It's kind of the same concept when you think about it. So we are putting a big emphasis on using whatever you could do with your hands, whatever you could experience in real life, and connect that to how the rules of quantum computing, quantum reasoning are. Yeah, so we don't want to just explain things without making any sense to anybody. Qubit swaps. We have a cat and a light bulb swapping really fast. Imagine you want to move an object, well, the information of an object without physically moving the object. How can you achieve that? I think IBM Quantum Experience had a prize, a $100,000 prize. If anybody could actually create an efficient, well, up to some error bars gate that would be more efficient than the standard quantum swap. Well, this module teaches everything about how you could move information around, what does it mean, why information is never lost, Zeno paradox, all those cool things about, we don't really go much into teleportation, but some of the core concepts are there. Basis transforms, you learn everything about basis. Did you know if you are in a H gate, if you are in the 0 state, in the Z basis, for those there who know quantum computing, I know some of you are, if you place a H gate, and if you would be aware that you could change the measurement basis to X basis, you actually no longer have a superposition. You have a definite 0 state in the X basis. We actually show you how that works and why it's a really cool thing. And it's a really cool thing because you don't have to think fundamentally anymore. You don't have to, oh, measurement, oh, I can't explain superposition. No, a superposition is all about missing some bit of the information behind behind the calculation you're doing. Yeah, I'll show you how that works. Another thing I want to point out, so everything is explained. Unfortunately, the slide bar is here. And it's also explained in CRPG style. So whatever word you see here highlighted, and there will be quite a lot of them, you could click on them, and this would open a lot of auxiliary information that supports whatever is being shown. It doesn't mean you have to read this in order to go further, but as I said, so this is a very CRPG style. So if you see the word, I don't know, Everett in a CRPG, you'll see it again and again and again. So that's the same way, each time you see qubit written in any of the puzzles, you could click on it and you could just read a bit more, then read a bit more, and then read a bit more. And sometimes only certain aspects you'd like to know about the qubit or remind yourself about it. So you'll always be able to just click and find it here, such as how to do basis transforms, yeah, or what the gates do and how you could jump around the gate, or what a H gate does. Yeah, a H gate is not a simple, oh, put things in superposition. No, a H gate is a 3-step rotation, guys. Yeah, 1, 2, and 3. And that's a fascinating thing that you don't normally see in any manual. Well, in most of the manuals. I know there are some that actually show that. So this is quite a big experience. You could zoom in, zoom out. The idea of solving these puzzles is pretty straightforward. I mean, if I just place a H gate here and speed up the process, I'll get my solution. I get a nice screen. For the first learning phases, we put a big emphasis on let's not make it as look like a challenge. So the moment you see the congratulations screen of a learning phase, so a puzzle that is instructional, it's not a challenge, you'd get prompted by some beautiful quotes by some smart people out there that have done amazing things in their lives. And we hope this will stimulate you to continue learning. The challenge phases will show you scores, will give you points, will give you metrics, statistics, and so on. Yeah, that's a big difference between. Well, Zeki, what would you like to do next? We could solve a puzzle together. I could explain the editor.
I think we can check the editor because I remember someone asking whether we can create our puzzles or not.
Oh, yes, definitely. So there are two things that I want to track with Quantum Odyssey to advance science. So this is not just about playing the game and learning, but it's also to advance science in a way. So the first thing would be who creates the most interesting and useful puzzles using Quantum Odyssey. And you could do, I don't know why this is, okay, cool. You could do it up to 5 qubits. Yeah, you could create some really large puzzles up to 5 qubits and many, many gates. Yeah. And the second thing, imagine 100 people solve these puzzles. From the 100 people, maybe 98 of them solve the puzzle and they use the same gates or more or less the same gates. Okay, maybe 30 solve it in one way, another 30 in the other way, another 30 in the other way. But there might be a handful of people, I know 1, 2 people, who actually use a way nobody thought about before, which might be less or more efficient. So we would like, through the game and through the ranking system we will implement, to reward in particular higher ranking points for those people who actually manage to find the unique or innovative solution to the puzzle. Yeah, so these are the key things that Quantum Odyssey will go for. First, is the puzzle you're creating really cool? Is it enjoyed by the community? What aspects of it are enjoyed? Is it because it's more educational or it's a really fun puzzle? Is it teaching some interesting concept or is it just pure fun? And the second, equally important, is anybody out there is able to find a more interesting sequence of gates or a particular way to solve a problem, which we did not knew it could be solved this way. So could you create a more efficient quantum algorithm to solve a particular challenge? So those are the things. The interface. So for those of you who have never seen this before, you start from 0, you get to 1 by placing a NOT gate. I think everybody knows that. You could get back to 0 by placing 2 NOT gates. Yeah, and if you get used to having this in your head at all times, then it becomes really simple to think about quantum algorithms. Check this out. So this is a H gate. The pictogram here is the same as here on a single qubit. If you would have 2 qubits, it would quite much vary depending on the position you're placing it. And you would immediately get the result. So this is the editor mode that allows you to create your own puzzle. Yeah, so 2 H gates, we split the ball in 4 places. The size of the ball shows the amplitude. The color of the ball shows the phase. Yeah, and you could have, of course, as a complex number, you would have something like this. Sorry, just a second. I think I can still do this. Okay, let me try. Okay, cool. Yeah, so what we have here is a mixed state. We have a control S. So this is entangling the first qubit with the second qubit using an S gate. And of course, this breaks the Clifford. And you have one big amplitude on the 0, 0 state, 2 small amplitudes on the 0, 1 and 1, 1. And can you guess what this is? I can tell you just by looking at it. So I think this is a 0.5 plus 0.5i, and this is a 0.5 minus 0.5i. And yes, you could use quantum odyssey to do your homework if you're studying a master's degree or whatever quantum computing course you're having. So you could create a gate, place it in quantum odyssey, save it. So let's save this test. So whatever I created here, this weird sequence, I can save it, or I could just design a completely standard gate, non-standard gate, and there you go. I have now a custom gate that does exactly what the other gates were doing. And the idea is, right, I could find a set of Clifford gates that could reverse back my state. Let's see if I can do it really fast. Okay, right, so apparently I'm not doing it efficient. Right now I have a Bell state. I have a 0, 0, and a 1, 1. I need more gate slots. So let me think. What if I remove the entanglement? Because as most of you know who know quantum computing, Bell states are really funky because without having entanglement, you can never obtain them. Yeah. So right now I can clearly see I have a 0, 0, and a 1, 0, which means on the first qubit, I just need to add another H gate. Yeah, a bunch of quantum interference, and there you go. I've completely brought back to ground state this weird looking gate I created on the spot. So this is pretty much the editor. You could save your puzzle, you could create it as a general puzzle. We want to have features that would enable you to create an entire learning module for someone else, for a classroom, for example, be able to rank your students, show in real time if students are solving the puzzles or if somebody got stuck somewhere, if it's a particular concept they got stuck at it. So we are trying really hard to push for really good data analytics behind whatever is happening in Quantum Odyssey. So Quantum Odyssey is connected to our private server, and most of the things you do with your consent will be stored on our private server and will be able to run data analytics and show your rank, show what other people do. Again, this is something that exists right now. We are gathering the data. We are still developing features in order to be able to express the data. So yeah, it's in progress to be able to see the ranks, but definitely it's in the pipeline of what we are aiming to do. Okay, so yeah, this is the puzzle. Let's see if, all right, this would be very complicated, but yeah, I'll just save it, test puzzle, and allow a bunch of gates to be used. Put it in intermediate level, saved. Right, and now we can solve the puzzle I just designed. Well, let's see if I remember how I called it.
I think it's test puzzle.
Yeah, thank you, Zeki. I appreciate it.
But it says easy. I don't remember you marking it easy.
Really? That's the one. Yeah, it's the right one. Okay, so now the idea is, can we still solve it? I clearly can see that we need to go back to the Clifford basis. Well, to the Clifford way of. Okay, cool. So now we have 0011. Remove entanglement, I believe, and then no. Okay, we need to remove the entanglement, not add CZ. Okay, I just solved the puzzle I created, and I got a bunch of points and some gamification on my screen. Yeah, these things are still work in progress. Like I said, it needs to be connected to the ranking system, and that's work in progress. Okay, Zeki, what do you think? What should we do next?
I think we can move to questions.
Okay.
If you allow me to share my screen.
Yeah.
Okay. Okay, you can see it, right?
Right.
So first question is from us. Actually, it's from Özlem, and the question is basically, which groups do you think would benefit the most from quantum literacy or the tool that you are developing? You know, high schoolers, undergrads, grads, people at industry. So do you have an idea? Or I know that you just started doing data analytics, but do you have a presupposed aim, let's say?
I can say colloquially, from a very beautiful experience I had was with a fresh PhD candidate at Durham University. I was not really I wasn't feeling certain if I did, if the development of the game is going the right direction. Should it be a computer game? Should it be focused on education? And he told me one thing, that if I had Quantum Odyssey when I was starting my master's, that would have saved me a lot of sadness or frustration. Yeah, so if you're studying STEM, I would really say it's a good thing to experience Quantum Odyssey, at least to decide if you really like numbers. Yeah, at least see them visually first before you go deep into numbers in general. And what would be really amazing is, as I said, people who study other topics to just learn a bit about quantum. That's the whole point of quantum literacy as a terminology that we are trying to coin, is we need to all be aware of how this form of logic works. What is different? Why the standard logic we've built for ourselves and built machines out is insufficient in some way. You could do a lot more. You could break out of P problems, go in some of NP problems you could solve if you would know some quantum computing. So if you're doing something that would ever be connected to numbers, I would definitely recommend Quantum Odyssey to get your feet wet into quantum reasoning. If not, then if you're interested about quantum and what quantum could actually do, again, I would highly recommend. So if you're not non-STEM, but you're just interested in the idea of understanding the universe and such, then I think we do a fair job. But at least we have thought experiments that I think are quite interactive and you could enjoy, although this is not something you want to study.
Okay, thank you. And I think this is related to our first question from Rahul from India. And the question is, I'm a computer science undergraduate final year. I want to pursue a career in deal something new like quantum physics, but I don't know where to start. So basically, can we say start from Quantum Odyssey?
Well, I would say that's not really fair to say. I mean, unfortunately, the way the education system works today, you need to know Schrodinger's equation before you do quantum computing, in a sense. I mean, if you're looking at going through the regular route, then I would highly recommend Quantum Odyssey to help you on your journey. So, yeah, make sure you really like STEM. I would recommend definitely to start with Quantum Odyssey. But when you make a career choice, I would say be sure that this is something that you see yourself 5 years time in. I wouldn't really just put my product out there as, wow, I solved the equation. No, I think there are many gatekeepers there. I think the education system needs a change. For example, if you really want to learn just quantum computing, you say here quantum physics, which wouldn't be fair for me to say you should start with quantum Odyssey, because we are focusing on quantum computing and just the gate model framework. There's a lot more to it. Yeah, if you want to learn quantum computing today, I don't really see a proper. I would definitely recommend Quantum Odyssey if you want to just learn quantum computing. But if you want to learn the aspects behind quantum physics, then I think you need to be surrounded by people who have similar passions and study quantum physics at the university.
Okay, great, thanks. And the second question is from Francisca. And I think she's also here as well. I see Rahul too. And the question is, I think, really good. How did you come up with the term quantum literacy? And you said you are trying to coin the term a couple of times. And why did you decide to use it instead of, let's say, the flagship term of quantum awareness? I know that they are doing a study right now to determine the term. Quantum awareness, quantum literacy, is there any difference? What are the other terms? I mean, what are your thoughts? How did you come up with the term? Who come up with the term?
Yeah, I see here 2 out of 29 suggestions were quantum literacy. That's really beautiful to hear. So we have computer literacy. I think it's pretty much well coined. I can't really recall who did it, but so we know quantum computers will not replace classical computers for sure. I mean, some problems are more equally efficient to be simulated on a classical computer. So we wanted to coin the idea of quantum literacy because to make it feel in a sense that it's a must. So either we are quantum literate or we become quantum literate. So we went and read everything from Bernstein to Young, the ideas of powerful knowledge. What does it mean when you have a knowledge that would be strongly benefiting society, that would give you a really highly paid career job, or maybe a fascinating job? Yeah, depends. But it's strongly locked in many years of understanding partially related topics. So we coined the idea of quantum literacy as a way to express that there are some challenges behind knowledge acquisition today, and we are trying to overcome those challenges and spread literacy over quantum computing and quantum physics. That's as much as I can respond. It was a thing that I remember me and my PhD supervisor were sitting in a room and we just wrote on the whiteboard, what about quantum literacy? Why we don't do that? Why we don't start a mission, so to say? It's one thing is to make a tool, but what does the tool stand for? And then we decided, because it should just be quantum awareness, then, well, it means that we don't really do it justice. It means that we just do a tool that could, it's not a Swiss knife, so to say. So we wanted to make, and we want to make quantum odyssey as a thing that covers really broadly as many things as possible. And that's what we are pushing for in the years to come. So that's why we said, okay, let's do quantum literacy as a thing.
Okay, so there's a related question from Gökner. Should I let her ask? Okay, so the question is, should this be a part of digital literacy?
I have not read the definition of digital literacy, and I'm not sure I can respond properly. I've read about many things on digital. Well, I don't know. I would let the person to do a proper review of our paper and decide for themselves if it should be or it shouldn't be. I think experts should do what experts do. Otherwise, we would run a Dunning-Kruger experiment right here in the podcast. Hope not.
Okay, thank you. So I'm moving to the next question. How can theoretical physicists get into the quantum technology industry? Why is PhD a requirement for it, given that PhD is training for people who would like to stay in academia, which is something I don't think so, but move on. Can a physics major master student with little research experience help out in quantum tech industry? So it's not really related to the topic, but it is related to the general theme of Q-World, Q-Webinars, and quantum industries in general, because it's a very rapidly emerging field. So what are your thoughts on this?
I think, Zek, you're more qualified to answer this one than me, who spent the last 3 years making quantum odyssey just. Well, okay, let me give it a try. I think right now we are building the hardware for it. And I think building hardware is a thing that takes many years and usually takes dedicated people who understand those problems for a very long time. So we are talking about, maybe here to jump a bit the topic. The first time I joined Durham University physics seminars as a computer science major, I just joined the physics team and started learning physics. I felt I only understood about 5% of what people were saying, because it was purely about Bose-Einstein and condensate, Rydberg, atoms and stuff like that. And then in 1 year, it took me to understand maybe 70%, but it would take me maybe a year to just understand how I could help, besides serving coffee, how I could help them design their experiments. So there are many problems there. And I think having a strong background, strong papers on a topic, and paying attention to what's happening today, what kind of quantum computers are being built, such as, I know, in optics, people are building quantum computers with photons, people are building Adiabatic quantum computers like D-Wave, annealing, quantum walks are being theorized and discussed in some ways. Open system quantum computers seem to be a thing. Now you could have, well, with optics, for example, you could have a quantum computer sitting on a desk. Some Chinese company made it for $5,000. You could sell it. So there are many startups coming out. And if it happens that wherever you're specializing, because you do have to specialize at some point, matches whatever the startup is doing, then I think that's a guarantee for a job. Unless during your studies, you come up with an innovative idea, like I tried and I'm trying and hopefully I'm succeeding. And then you could get financed to do what I'm doing right now, to start a company in which the mathematical expressions behind quantum odyssey, we patented them to be able to sound nice for our investors. That's the main aspect why we did it. So you can start your own company, do good research, and opportunities would come. That's what I like to think. Yeah, we live in a fair world, and if it wouldn't be capitalist, wouldn't be working, right? If good ideas would not thrive, then we don't really have a successful economy, do we? Yeah.
Yeah, thank you. So the fourth question is, I'm a physics teacher. Teaching is my passion. I have already taught quantum physics. How can I prepare myself so that I can contribute to quantum literacy in future?
So yeah, I think if what I would like to see, and I'm also part of the IEEE committee for quantum education, and I also joined Quantum Flagship recently. We really need to see more pure quantum computing / quantum programming classes in schools, I think. So I can't really answer the question about quantum physics. And as I said, the idea of quantum literacy, for me, first and foremost, has to be, do we understand quantum reasoning? Are we able to use quantum computation and the ways atoms work to the extent that we could use those phenomena to solve problems we care for? That's for me quantum literacy. Understanding the core basics of how universe functions and harnessing that power in order to be able to solve some problem in economy, in, I don't know, optimization that we actually care for. So definitely I would say, and I'm starting to recommend, and we also through APS, American Physical Society, will be giving Quantum Odyssey to schools in the US. For example, that's a thing. You could pick up Quantum Odyssey and send me an email and I could give free licenses if there is no budget for it. That's not a problem. We want to spread out quantum literacy and teach quantum computing, teach the ideas behind understanding these phenomena as widely as possible. That's what I would say would be really cool. Yeah.
I think the next question is related to what you have said. So the question is, what can we do to increase quantum literacy in Africa? So Lorraine is from Zimbabwe, and we know her. She will probably join QWorld at some point. So do you have any ideas, suggestions?
I think, well, I don't really want to just sell my product here, but unfortunately, that's what I end up doing. I put a lot of effort to make sure that we are able to create a method that no matter your background, no matter if you're in Africa, Asia, US, well, North America, South America, wherever, it's the same thing. It's a visual method. It's those pesky hieroglyphs. and you could just pick it up and play it. So if we get people involved in playing and understanding through our visual methods, I think that would really increase people's likelihood to want to study quantum computing further or want to do something quantum computing inspired or use quantum computing to some body of knowledge or some other field that we never knew it's a thing that we could be using it. So I would say use the most efficient method on the planet and promote it.
Thank you. So the last question here is the one that I love the most. So can quantum computing help to resolve issues like people mind purification to be a better person? So the question is basically, can quantum computing help you to be a better person?
I don't know who said it, but of course I know. Carl Sagan did. Please watch Cosmos from Carl Sagan. All the episodes, it's a must. If you are attending Q World, you must have watched at least Carl Sagan Cosmos. So that was a brilliant mind who found an elegant way to make people excited about his field, cosmology. And he said one thing, which I'm pretty sure I'm going to fail to quote him precisely. He said that the pursuit of cosmology is a humbling experience. I think it's what he said. So the moment you, and at least watch the pale blue dot, if you go on YouTube and write pale blue dot, it's a really beautiful snippet from one of his videos. Yeah, it's a pale blue dot we live in. All the wars happen on the pale blue dot. Everybody's sufferings, everybody's problems, our daily lives and all their struggles happen there. But if you zoom out strongly enough, all you see is a pale blue dot. I think in a nutshell, that's what he talks about. And I think that idea, that core concept is really powerful and it cleanses you. And I think, I don't know if I should go deeper into some philosophies of mine, but I'm thinking if somebody is really angry at you, and if you respond with anger, that feels a bit, that you fail to understand this person. So if you're thinking somebody wants to do something and he feels that he has to do it, there is a motivation there. So nobody's evil by nature, I would say, with some exceptions, of course. But there are intents there that are justified. Everybody could justify in some way. Some countries, terrorists, in other countries, freedom fighter. It's always been like that since the beginning of time. And I think it is. I think it is. I think studying science definitely opens up some doors in your mind and makes you a nicer person to some extent, and to some. You can never be overall perfect. So, yeah.
So you are saying that studying quantum computing will make us better people?
I can't even disagree with that. I mean, the moment you understand how superficial the logic, the common sense we have with those sentences, if A, not then B, and we've built everything we have using those sentences, and you understand there is so much more to it, and this idea of quantum interference, you could completely annihilate events, and entanglement, as a beautiful concept as it is, and please don't think of entanglement without thinking that it travels faster than light. That's not true. It's a resource that exists. And yeah, so definitely it is. And whatever perceptions you come into studying quantum mechanics, especially quantum computing, because it goes exactly on those aspects of quantum mechanics, which are profoundly interesting, I think the more likelihood there is that your character will be altered in some way, a positive way, hopefully. Yeah.
So we have another question from the chat. Did quantum computers solve any problems that we care for, or we need some more development?
That's a really good question posed by someone who I believe knows about quantum computing, and that actually tests the limits of my knowledge. Well, for example, in our mission video that I showed at the beginning, I'm showing a glue trees graph. And it's proven that using a quantum walk coin, you could always have a quantum advantage. So clearly there is a set of problems that, well, will never be satisfied as optimally using classical computation. Strong example is Grover search. Unfortunately, it uses an oracle, which is something arbitrarily decided in advance, and oracles don't exist in real life. But again, the diffusion operator from Grover search shows that you could efficiently and beat any kind of exhaustive search, given exhaustive search is the only way to calculate an unsorted list, by square root of n, speed up. I think maybe Zeki knows more and others. I haven't been paying too much attention. I've been reading about quantum advantage lately, but I think the person who asked the question knows that most of the problems who have been proven so far are toy problems. And yes, we believe there is a future for quantum computing. A clear one is chemistry for sure. There is no way you could ever simulate classically something efficient happening on the atomic level. And I think Richard Feynman said it better. If you want to make a simulation of nature, you better do it quantum mechanically, damn it. So, yeah.
So a follow-up to that question is, do we need theoretical or experimental developments?
What I really think we need, and that's why I actually made Quantum Odyssey and I'm pushing this idea of quantum literacy, is we need creative thinking. We need more people than what fits in the box. I think all the experts in quantum gate model right now would fit in a room, in a large enough room. We need people who don't go to these events, who don't go to all the quantum error correction talks, all these seminars, but people who could just pick up quantum computing and in their field of study, actually come up with some really clever way in which you could use quantum interference for something or entangle a bunch of results. So if you believe most of the information in the world could be encoded to numbers and expressed numerically, I'm not just talking about standard numbering set, but complex numbers, quaternions, whatever, then there is a strong proof there. By just playing Quantum Odyssey, I think you could observe that there is no way classically you could do this. Yeah, to collapse all those things that have phases and get your answer faster. Yeah, it's there. That's how nature works. And now we start, and if you play Quantum Odyssey, you understand why. We start to use a new logic, this quantum reasoning. And again, you need to know the problem first and foremost. That's usually the problem. If a physicist sits with a chemist today, the problem is the dialogue. There is no efficient dialogue between the chemist and the physicist. Everybody's an expert in their own field. Knowledge has to sit in the same brain at some point, at least to be able to formulate the problem. To solve the problem, definitely we'll have many people working in parallel, hopefully, to find the most optimal one. But to just be able to formulate the problem, you need to be a chemist who knows something about quantum, I would say. We need people who break barriers. And I would start with computer scientists. I would start in every class around the world where people study computer science to just have one course, an optional one that teaches quantum computing. I think that would be a really strong push.
Thank you. Yeah, I think that's an important point as well. So we need those courses at engineering departments, and especially for computer engineers or electronic engineers. Do we have other questions? So maybe I can ask, what's next? What are you planning next?
Well, I mean, I dream about doing research again and coming up with some clever idea again, but I don't see it happening very time soon because I just want to focus on Quantum Odyssey for a while, really make it work in a sense, make this a successful video game, a successful learning platform, whatever people are looking for in terms of pursuing quantum literacy. I want this game to really deliver. I'm really happy the results so far when it comes to rating are nice. We're improving it. But again, I have no idea how to commercialize it properly. I have no idea who even the target audience for this game is. As I said, I'm trying to make it as inclusive as possible. So right now I'm interested in teaching, in a sense, showing the game, doing seminars, webinars such as this, and just pushing for the mission, and at the same time, just developing the game further. And yeah, if you want to collaborate with me, just drop me an email and we can work together.
This is just out of curiosity. Do you have any plans to make mobile versions like Android or Apple?
Definitely. Right now we are focusing on porting it on Macintosh and Linux, which shouldn't take us more than a month. And soon, once we clarify a bunch of things, because we are a small company, as you see, and the resources are quite limited. What I'm looking for is maybe bringing some ZX calculus, actually doing something more elaborate in a sense. If my dream is to have a software that you could just launch and explore to the maximum, to the state of the art of today of what you can do with quantum computing, in a sense, as it is a simulation. Then I need to focus on this. To port it on mobile, I know I have to do at least four to 6 months of additional work, which would take some time. And I'm also not sure I can give you on the mobile phone the same experience I could give you today using 5 qubits and so on. There are many questions there that are still lingering around, but definitely we are considering Android version. And also we need a strong team that would not be afraid, because I'm not going to port it on my own, that's for sure, to sit with me, have a whiteboard in our background and decide, yeah, how we could process some gates faster using, I don't know, the latest CPU from Apple or whatever for an iPhone. Yeah. So for sure, but it would take some time and I need to find the right team to port it also. So it's in the pipeline, but I didn't start to do anything there.
Yeah, thank you. So we have some notes at chat from Gökmen Hoca. Okay, if nobody has any other questions, you can just unmute yourself.
Thank you very much.
Anytime, Gökmen, it was my pleasure.
I just wrote something like maybe a light version of the real game for the mobile versions.
Yeah.
Not the whole 3 chapters, but maybe the first chapter who introduces the basic concepts. It will be nice because when you talk about it, I just go to App Store and type in Quark Interactive, so, and nothing came up. So it will be really great, especially for the younger generations to play and learn and get interested in quantum computing.
Yeah, for sure.
Thank you again. And maybe if I can complete my workings, I would love to collaborate with you on the quantum literacy part, because I kind of skimmed the paper, and it's great. I really like what you did by coining the term, and maybe we can kind of extend it a little bit since we are working on the educational side right now. So anyways, thank you again for this lovely seminar at this hour.
Thank you, Gökmen. And definitely, if you can drop us an email, I can just write here. I don't know if... So, yeah, this is my email address for my company side. Drop us an email and we can connect with the rest of my team, and definitely we can discuss how we can extend the research. It would be really lovely to do so. Yeah.
Thank you. Thank you again. Bye.
Bye.
Okay, so we want to thank Laur for this great webinar and accepting our invitation. And we want to thank to our participants and everyone who joined us on YouTube. And if you're interested, check the website, play the game, and you can reach Laur. I mean, it's really easy to find his profile, but we will also add any contact information on YouTube as well. So,
thank you to our lovely moderators as well. Thank you.
Yeah, thank you.
Ladies and gents.
Okay.
Are we still on YouTube?
I think we are, but we can go. Have a good night.
Thank you. Have a good night.